Hello, boys and girls, children of all ages. Today we're going to look at absolute value inequalities with one variable. So we just did that Desmos activity where we were kind of looking at absolute values. And so here's our formal steps. The first thing you want to do is isolate the absolute value expression. So if we look at example 1, notice the only isolate means to get by itself. So the only thing on the left-hand side for now example 1 here is the absolute value. So step 1 is done for example 1, and we'll talk about how to do it for the other ones shortly. Once that absolute value is isolated, you want to make two separate inequalities. Inequality 1, you drop the absolute value symbol and keep everything else the same. So if we look at our example here, my one inequality, I drop the absolute value, so it's just x plus 2, then everything else stays the same, less than 2. My second inequality, I'm going to drop the absolute value symbol again, change the direction of the inequality, and make the non-variable side, which is usually the right side, negative. So, again, I drop the absolute value on the left-hand side, so I'm left with just x plus 2. I have to switch my inequality, greater than, and right side only becomes negative. So there's my two inequalities. Step 3, solve for the variable, and then write as two inequalities, graph on a number line. So I have minus 2, and I get x is less than 0. And then I subtract 2, x is greater than negative 4. The last step is if the shading is in the middle, add the word and in between the inequalities, or you can write into a compound inequality. And again, a compound inequality is where you have the x in the middle and something like this. So if I had it like negative 4 is less than x, which is less than 5, something like that. If the shading is on the outside, add the word or in between the inequalities. So if I graph these on a number line, here's 0, negative 1, negative 2, negative 3, negative 4, negative 5, here's 1. I have an open dot at 0, open dot at negative 4. So I have x is less than 0, so that'd be going this way. X is greater than negative 4 going this way, so my shading is in the middle. So I'd add the word and in between. And again, I'm adding the word and because my solution has to be less than 0 and at the same time greater than negative 4. Satisfy both. The other way we could write this, I could write it as negative 4 is less than x is less than 0. Either one would work. You do not have to have both, just one of those ways. So if we look at example 2, it says isolate the absolute value expression. And the way you isolate it is to undo. So you do PEMDAS backwards. So undo an addition subtraction from that absolute value. So I have a minus 2 here, so I'm going to add 2 first. So I get 8 times the absolute value of negative 2x is greater than 32. I then have to undo multiplication. You cannot distribute through an absolute value, so I'm dividing by 8. And I get the absolute value of negative 2x is greater than 4. Remember, this is where we're going to write our two inequalities. So I get negative 2x. I drop the absolute value, keep everything else the same. And then my second inequality, drop the absolute value, flip the sign and make the right side negative. I then am dividing by -2, so I have to again flip my inequality. So I get x is less than -2 now. Same thing, I'm dividing by -2 again. So I have to flip my inequality, x is greater than +2. All right, I'm graphing this on a number line. Here's 2, 1, 0, -1, -2, -3, and 3. I have open dots on -2 and 2. And now I look at them individually. X is less than -2, so the arrow is pointing to the left of the -2, so I'm shading this way. And the arrow is greater than 2, and so the arrow is pointing to the right, so I'm shading that way. And so I have to use the word or. And so my answer would be less than -2 or greater than +2. You can't have a number that's in both this shaded region and this shaded region at the same time. Also remember, shaded region means it's a solution. So anything in the shaded region is a true solution for it. It would make the original inequality true. All right, last example. For example 3, again, I have to isolate the absolute value. So I undo addition subtraction first. Again, looking at PEMDAS backwards, undo addition subtraction first. So I'm adding 4. And I get the absolute value of 2x minus 17 is greater than 9. The absolute value is now isolated, so this is where I can make two inequalities now. I drop my absolute value, keep everything else the same, drop the absolute value, flip the inequality sign, and make the right side negative. We make two separate inequalities now, we're solving two separate inequalities, so I'm adding 17. So I get 2x is greater than 26, and when I divide by 2, x is greater than 13. I add 17. I get 2x is less than 8. Divide by 2, x is less than 4. All right, so when I go to graph this, I'm going to put 4 here. That would be 3, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, I have open dots on both of them. Again, the only time it's closed is if you have equal to. It just so happens all these are not equal to. So I have x is less than 4. Shade going that way because the arrow is pointing that way. And then x is greater than 13, open dot on 13, and I'm shading to the right. And again, if the shading is pointing outwards, I have the word or. So again, this is your algebraic solution. This is your number line solution. You need both.